homework, introduction and description. First, the link to your homework is here. If you click the link, you will land at this page. All the homework is described. Here is your goal. Here is to-dos, conditions and the simplifications for the task so that you won't forget them. Then links and papers to reproduce. Some of them contain source code, some of them don't. It was done intentionally so that you can gain experience implementing the models and approaches on your own. Then some ideas which appear to be crucially important in the practice. And I'm just sharing here them with you. Here is the link to the data set, as well as to the paper introducing the data set. Here is the starter notebook specifically for this data set. It gives you ability to visualize the data, understand the distributions, features, targets, etc., etc. There was a Kaggle competition on that data set, but there are no solutions on the Kaggle, so don't try to. Now I will go a section by section about your homework so that you have clear understanding of what you have to do. First is the goal. The goal is simple and difficult simultaneously. Simple because it is simple to formalize. We have to maximize investment return. It means we took to the exchange like X of money, and we want to end up trading the top multiplier per X money back. Maximization of investment return. Why it is complex? Because it is not easy to achieve that. There are a lot of smart traders. There are a lot of algorithms and bots on the exchange already. So you're going to compete them all, and you have to be really outstanding to achieve something. Here are your to-dos. The first to-do will be like typical for any machine learning task. It's implement experiments tracking frame. To have the ability to compare results of experiments, it is strongly recommended and required in the scope of this homework to implement frame for plotting of a P&L curve, which agent achieved together with a midpoint price overlaid with agent states and actions. These plots and logs will give you intuition of where you are, compare different approaches and models. You have to start from the first model. The first model is not actually the model, but rather a hard rule algorithm. It's a baseline in order to compare the rest of algorithms and approaches success to it. It is very naive, buys one share at the beginning of the trading day and sells this share at any price at the end of the day. The rest of algorithms will try to beat the baseline. There are 2 approaches and 3 algorithms, which will be required in the scope of the homework. First is a random forest. This is one of the simplest examples of supervised learning approaches. Tries to predict future price of the stock so that we can trade it. Either can predict regressively future price, which appears to be more difficult, or predict future movement of price, classification instead of regression. And so we just try to guess whether the price will grow or drop or stay the same. Then we will switch approach globally and turn to reinforcement learning. And there will be 2 algorithms required to implement. DQN, particularly double-dueling with a prioritized replay memory, and the PPO. The huge benefit of reinforcement learning, the outcome is not a prediction of a price, direction of movement, but rather the agent trades direct. We don't have to do any additional efforts working with the outcomes. You will have to compare the results and make conclusions. This is the most important and significant part for you, because it will grow your experience as a professional and give you some insights into the industry. For the agents, I will ask you to limit your action space to 3 active actions. The agent can either buy or sell or hold. It turns to be useful to implement daily stop loss or daily take profit. The outcome of each action of agent depends on the agent's position. There are 3 possible positions: neutral, long, and short. Neutral is when we haven't submit any order to the market yet. The long, if we submitted a buy, and the short, if we submitted a sell order. And yes, it is a bit weird, but it is possible to sell a share without owning it. Long is buying, then selling, and short is selling, then buying. Long expects the price to grow. Short, on the contrary, expects the price to drop so that the sell price will be lower. A position action pair means in which position agent resides and which action the agent decided to do will define how the agent will interact with the environment. If agent is in neutral, it can either buy or sell. If it buys, it goes long. If it sells, it goes short. Then the following positions correspondingly are long. In long, agent can only either hold and stay in long further or sell and go neutral. Being in long and owning only 1 share, and I recommend you to start with only 1 share. It will simplify your life a lot. If we are in long, we cannot buy no more because we already bought our 1 share and we are in long. So the agent, if agent buys in long, nothing happens and agent resides in long further. Let's consider second path. We've been in neutral, then we sell 1 share and we reside in short now. In short, we can only buy. After a buy in short, we are getting back to neutral. We cannot sell in short because we already sold our 1 share, which moved us to the short state. As well, the agent can hold in short and reside in short further. So those are important dependencies for your reward function. All this concludes the interaction logic of an agent with the environment. State space, as you know, is your state of the environment at some particular point in time. And the good news is that the state space is given in the data set. State space also described in the paper, which I will talk about later, as well as results. You can experiment with different features, adding or removing them. But briefly, a state space contains volumes and prices for limit of the order books for the first 10 levels on both bid and ask sides. And I will explain you what is it soon. The state space also contains agent's current position. It is important meta information so that agent knows where it is now to better consider future action. This feature turns out to be useful. A mark-to-market value is amount of shares multiplied per current price of a share, and all of that conclude the current worth, net worth of an agent. So agent knows the structure of the asks and bids. The agent knows in which position it resides currently. The agent knows how much it's worth currently. The bid-ask spread is difference between the neighboring best ask and best bid. Then we have states of the limit order book for the last 9 ticks. Data split is train test split, and the good news that it is given in the data set. You will not have to bother yourself splitting data. The exchange we will work with is Nasdaq Helsinki Stock Exchange. Shares to trade at once. 1 share. Your core performance metric will be P&L or profit and loss. There are 2 possible groups of transaction fees. First one is fixed. You simply pay per year. The second option is more detailized fees. You will have to study them and decide which one to use, which makes your agent more profitable. This one penalizes per transaction. More transactions, a greater fee. And then here we have papers to reproduce. To simplify your life, I already prepared the resources that you will need to complete your homework. Random forest. Here is an article for random forest as well as source code. Yes, you will have source code for that. You just have to go there, copy paste, run it, execute, train some agent just to have your hands on and see some results. Here is the article. It is made on a different data set. So just omit the data section. There is a GitHub repository. Here it is. The guy used random forest to forecast mid-price dynamic. This is exactly what we want. He did it for a couple of time horizons. Yeah, and here he describes his code structure, labels. We will have the labels, features. We have the features. Calibration is hyperparameter tuning. Take this code, run on the data. You can go to a data section and upload our data set. Related paper has name deep reinforcement learning for active high frequency trading. It's also made on a different data. It's on a lobster, which is unavailable. Let's quickly go over this paper. They describe the data, they describe how their training set, then they describe models and setups that they used. I summarized them here. Here they describe, and this is important information, what actions can agent do at different positions. That paragraph very clearly describe which actions in which positions the agent can do. I recommend to pay particular attention on that. It will conclude your reward function. Reward function is described here. You calculate P&L based on each position and each action. I will talk about data in the next section. What you have to know at this moment, that your homework has a link to the data set itself. This is the link. It has short description. Plus, here is the paper which describes the data set. If you don't understand any of the details of features and stuff of the data set, please refer to the paper. Starter code with the EDA and visualizer for this data set.